everyone, welcome back to my channel. Today we're looking at recognizing relief features. Of course, you can see different patterns on the board which are actually showing different relief features. Okay, different features as it relates to the height of the land. So of course, contours are used to show the height of land above sea level, these lines that are drawn on the map. And they show the shape of the land, they show the height of the land, as I mentioned just now. They also show how steep the slope is, how gentle it is, the different shape of the land. Okay? So here we are seeing this feature here. The highest point is 50 meters. So if you see on the map a series of contours shaping like these, see one shape like this here, another shape like this here, another shape like this here, we know that there would be conical hills. Okay, so we can label this one as conical hill. So this is a conical hill, and we look at this one here. If you notice that the contours are elongated, okay, wide width going out, wide could be wider than this, then we could say it is a ridge. Okay, looking at this one now, when the contours are elongated and there is a flat top, okay, there's no number at the top. See, number is here 150 meters, there is none here, or there's none here. It tells us that with the flat top and no number there, it tells us that it is a plateau. A plateau. Okay, looking at this one now, if the contours are circular or oval in shape, and the highest point is actually below 600 meters, this is 250. If it's oval in shape, as I said, or circular, and the highest point is below 600, we know it is a hill. Do not mistake it with this though, because remember, the hill is usually higher, having a higher number at the top, and you would have to see a series of these on the map to say it's a conical hill, okay? Looking at this feature, we can see that the contour lines are a bit circular. So whether there are circular or oval contour lines, once the highest point is above 600 meters, then that tells us that it is a mountain, okay? Here we can see that this rises to 6,000 meters, all right? Or just above 6,000 meters. So we know that this is a mountain. Now taking a look at that feature, notice it doesn't look regular. It's not showing elongated. It's not showing oval. It's not showing circular. It is looking, as I said, quite irregular. And so if you notice that you see 20, it starts at 20 there, right? 20 meters, and there you see something, not sure what is going on over here. You see 40 there, see there. So it's quite irregular. So when it's like that, we describe it as undulating. Yes, up and down slope, we describe it as undulating. Undulating. Okay, now that is all about recognizing relief features. Those are the main relief features to be identified. What I do, I go straight into calculating gradients, because when we talk about gradients, we're talking about the steepness or the gentleness of the slope. Okay, looking at calculating gradient, we calculate gradient with the formula, as you know, vertical distance over horizontal distance. So VD over HD. And we know that the gradient is given in ratio. Okay? Alright. So how do we get the vertical distance? We get the vertical distance by subtracting the smaller contour number from the larger one. Okay? So if we work with an example, there is nothing here that is drawn to scale. Okay? And I just have an example of what a scale would be like, so we can work with it right here. Okay? So there's nothing drawn to scale. So if we're looking at calculating the gradient between A and C, so that's between A gradient between A and C. Okay? So the vertical distance now, VD would be what? That would be 100 from 140. We're left with 40, right? So it would be 40 over, how do we get the horizontal distance now? So the horizontal distance, you know, marking off both points on the map, use a straight edge. It's good if you could use a paper. It's workable. Making sure that the edge is straight. Place it. So my first point, I'm going to mark it exactly where the contour is. Okay. And right where the contour is, right there. And then I place it on my scale. So whatever scale that you have on your map, you're placing it on the meters section. Usually the kilometer is out here. You're placing it on the meters section. And of course, you know, you're starting at 0. A first point here. There. And 0. And wow, this is 500 meters, right? So that is 40, which is VD. VD equal 40 over 500, which is HD. And then what are we going to do? We're going to divide, yes? What would that answer be? You work that one out. And remember, whatever fraction we get, we're to express it in ratio. How are you getting on with that? So as you know, in calculating gradients, the answer should be in the form of a ratio. 1 to whatever it is. Okay, so if we should divide both of these by 20, we will get 2 over 25, and we want to get it to the lowest, okay? So that's 2 over 25, and then to get that in ratio, we would have 1 to 12.5. 1 to 12.5. And you know what this is saying? This is saying for every 1 meter that the land rises, you travel 12.5 meters. Let's look at another example. What's the gradient between B and D? Let's write that. B and D. Let's write this a little brighter. Good. B and D. Okay, so D is 20, B is 80, right? And so VD would be 60 over HD, B and D. So B here and D right here. Okay. So it's these 2 points, yes? So we started here. And if we mark off, make it a long one, so we know this is where 1000 is. So that's 1000 meters, right? We still have a bit more to measure. So from here to there. And this would be approximately, see, 100, 200 meters, 300, 400, almost half there, about 450. Yes, if we add that together, oh, I wrote 100 instead of 1000, right? So that's 1450 meters. 1450 meters. Okay, so we need to do a division. Okay, get a calculator, divide it, and let's work it out to the lowest and do the ratio. So to get the fraction, we divide by 10, divide 60 by 10, divide 1400 by 10, and we end up with 6 over 145, and then we divide both sides by 6, and we would end up with 1 to 24.7. Okay, that means for every meter we ascend vertically, we would actually travel 24.7 meters. Okay, so let's look at both. We have done both gradients, yes? And if you notice that the first gradient that we did was 1 in 12.5. 1 in 12.5. Okay? So if you notice that this gradient is smaller than this one. Okay, what does that tell us? That was between A and C. It actually tells us that this has a steeper slope. Okay? So the smaller the gradient, it's the steeper the slope. And right here you can see that the contour lines are closer together. So when we see the contour lines closer together, we know that the slope is actually steeper. So if we're going to go hiking, yes, or whatever we plan to do, and we should look on the map and we see the contour lines closer, we know that the slope is actually steeper. Okay, so this one is 124.7. That's between B and D, and there we can see that it's a gentler slope. Okay, so as usual, I encourage you to continue to practice and that you will do well in your exams, or if you're using this video to help within your classes, that the students will learn well. And please remember to subscribe